questions. Ella, you want to start? Sure. Paul, what's up? 44? Yeah, man. So 44, Matt hits a baseball 3 feet above the ground, initial velocity 115 feet per second. The ball leaves the bat at an angle of 41 degrees with the horizontal. Heads towards a 20-foot fence that's exactly 380 feet from home plate. So we'll start by writing our parametric equation. So x of t is the initial velocity, cosine theta times t. Y of t is negative 16t squared plus initial velocity sine theta times t, and then plus the initial height. That's part A. Part B says if no fence or other obstacles were present, find the distance the ball would travel when it first hits the ground. So like here's the ball from the initial height, and we're basically looking at that kind of path. So the xy here, we don't know what the x is, but we know the y has to be 0 because it's on the ground now. And we want the t in that situation. Okay with that?
Yeah.
To
Negative 16.
It's part of the formula.
Oh.
Okay. So to solve for the t, I'm just going to plug 0 in for y. And then we'll just use the quadratic formula to solve for t, since that's a quadratic equation. Cool there. Typing this into my calculator, I'm going to use alpha and y equals to create the fraction command. That'll make my life a little bit easier. So I'll do negative 115 sine 41. I can't do plus or minus on my calculator. I'll just start with the plus. And then square root. Now I got to make sure I put that 115 sine 41 in a parenthesis because the whole thing is squared. And then minus 4 times negative 16 times 3. And we'll all divide by 2 times negative 16. So I get 0.394-ish, well, or negative, but I know that's Garbo. I don't need that. I want a positive value. So I'm just going to go and change that to the minus. I do that, I get 475-ish. So to figure out the how far then, since I have the t that it took to get to 0, I'm just going to do 475 of that t, or x of that t. So 115 times cosine 41 times that t. So 412.7 feet-ish. Is that okay so far, Paul?
Yeah, so could you say again why you use the y equation instead of the x?
What coordinate is this?
Oh, okay, so that's the
Y coordinate, right? So I got to use the y equation.
okay, gotcha. And the y, you put 0 there because it's not hitting any fence.
Because the question says when the ball hits the ground,
Okay.
the ground is 0 height.
Ground is 0, okay. If there was a fence, you would have to find the range, right?
Well, let's look at part C. It says, will the ball clear the fence? If so, by how many feet? If not, will the ball be catchable, i.e. less than 10 feet? So drawing a picture, kind of the same situation, except we have a fence here. The difference here is that we know that fence is 385 feet away, so we know the x coordinate this time. but we don't know the y coordinate. So again, we want to find the t then when x is 385. So we'll just plug 385 in for x. And that's actually easier to deal with because that's a linear equation instead of a quadratic, so the solving's considerably simpler. Right? I'm still going to do the fraction command though, alpha y equals. So that's 0.44-ish. And now that I have that, I plug that in for y, and it'll tell me the height when I get to that spot. Keep in mind, what mode is my calculator in while I'm doing all this stuff? Good. So 22.8 feet high. And since that's greater than 20 feet, we got a home run by 2 point whatever.
Wait, is 150 cosine 41t, is that xt or yt? What was the original? Okay.
X of t.
Wait, can you solve that for something?
How about I do that and just size it so it all fits on the screen at once and we can all look at whatever part we're interested in. Yeah, what's up?
When you're trying to find the range, you're plugging in numbers for y of t, and when you're trying to find the domain, you're plugging in numbers for x of t.
I would think about it instead. If I'm looking for a horizontal distance, I'm using x.
Okay, right.
If I'm looking for a vertical distance, or I know something about a vertical distance,
Okay.
I'm using y, right? So just depending on what you have, you got to use the equation for what you have.
Okay.
But if once you do that, you get the t that'll get you you can plug into the other one to find the other piece that you're looking for.
I don't know what I'm thinking about right now, but like, for some reason I'm thinking that you used the y equation for horizontal.
So here's what I did. Yes, in this piece I'm looking for, in part B, I'm looking for a horizontal distance.
Right.
To get that horizontal distance, I need the t that associates to that horizontal distance.
Okay.
I used the y equation because I knew what y was
Okay.
to solve for t.
Okay.
Once I had that t,
Right.
I plugged it into the x to get my answer.
Okay, so you did. Okay, so x was.
Remember when we're doing these parametric equation, your input is a t, the output is an ordered pair, right? If I know the t, I can get both the horizontal and vertical distance. If I know a horizontal or vertical distance but not the t, I have to solve for the t to plug back in to get the one that I'm missing.
Okay. So you plugged it back into the equation of xt equals 15 cosine. Right.
Right.
Okay. So I just did this before.
Yeah,
Okay.
it's because I
got it.
just did on the calculator.
Yeah, I see. All right. Gotcha.
Okay.
And then you just kind of did the exact.
Except the opposite, right? Because I started with, I'm looking for a horizontal.
Okay.
So I started with the vertical, I'm sorry, looking for a vertical. I'm looking for a height. So I had to start with the horizontal, find the t, plug it into the vertical.
So you have to find the t point. Okay. And that only worked because we knew y was 0. Okay. I see what you mean. Because it was
Hitting the ground.
Okay.
Yeah.
That makes sense now.
Yeah. So again, the way you're thinking about it is like you're interested in that position at the end.
Right.
You need one of the two coordinates
Right.
to solve for t. Once you have the t, you can plug back in and find the other
0,
coordinate.
we knew that. Okay. I see what you mean.
Okay. Does that feel a bit better?
Yeah, that helped a lot.
Okay. Amy, I see you keep tentatively like. Yeah, it's the exact same problem except the numbers are different.
I just got lost at the first page. Like, I understand how to get the equations. I'm just getting a little lost when we do the actual calculating. Like, my numbers are coming out a little weird. So.
Do you have it in your calculator?
No, I think I'm in the wrong one.
Okay. If you showed me what you typed in, this sounds very specific, like, you know.
For the last one we just did, but I just looked and it was a gradient set, so I should be fine.
Okay, yeah, so certainly that's going to be a problem, right? If you weren't in degree mode, like there's no shot at getting the right thing to come out.
Could you just go through a quick second picture? Like, did the steps the right way?
Do you want to know what? Sure. Why not? It's fine. All right, so we wrote our parametric equation. So what do we have? We have 120 cosine of 30t y of t equals negative 16t squared plus 120 sine 30t plus 4. So again, we have some 4 feet here. We hit the ball, goes over here. We don't know what the x is. We know the y is 0, so we want to find the time when y is 0. So it's a quadratic equation. We'll solve for t, so negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. I'll go to my calculator. Alpha y equals fraction command negative 120 sine 30, close my parenthesis. Can't do a plus or minus, so I'll just have to do them separately. We'll do the plus first. Parenthesis 120 sine 30 squared minus 4 times negative 16 times 4 divided by 2 times negative 16. So Amy, important here, make sure you're looking at, oops. How I typed in that 120 sine 30 squared. You see all the parentheses there that I had to use?
Yeah.
Got to make sure you do that. If you goof up those parentheses, you're going to get the wrong answer. So 382 is what I'm looking for there. And now that I have that, I can do x of 382. So that's 120 cosine 30 times 382. So 396.5 should be the how far that goes. Is that okay?
Yeah.
When you say x equals 382, you're just plugging 382 into x.
That's 380. That's x of 382.
Oh.
That's not times because x is a function in terms of t in this equation, right? So I'm plugging a t value into my x of t function.
So 3.82 is just plug in or substitute for t.
Right? That's what I've done there to the right. 120 cosine 30 times 382.
16 itself, like the negative 16 thing, that's just like a constant.
Yeah.
Okay. Okay, so when you plug it into X, that's giving you distance.
Horizontal,
Horizontal. Yeah.
right? If you think about on your plot, X's go left and right.
Correct.
Yep, and Y's go up and down, vertical.
So.
And then the y one is just the radius.
And to find out if the ball will clear the fence, you just plug in into T, you plug in.
Into X,
Oh, okay. Into X, you would plug in.
how far the fence is away. Yep,
And you would find.
find the T.
Okay, fine. That finds your T. So you're plugging that into X, 350. Okay, so you plug that into T, and then you get whatever, and then how do you find if it clears? That's the part I think I'm a little bit.
You just need the height when the ball is 350 feet away,
Okay, gotcha.
right? So so once you have the T when the ball is 350 feet away, you just plug that T in for Y of T, and that gives you the height.
Okay, so my new T would be negative 16, 300.
Let's just do it. Let's just do it. This is,
Sorry.
that's okay. So again, this is what we're doing, right? We're 350 something. We need the T when X is 350.
Oh, so it'd be 350 equals. Oh, I get it now. I get it. Yeah.
It's just
And then you get
by the code.
whatever that.
You take the absolute value of the code. Multiply together.
Okay.
And then we'll just do Y of that, whatever that number is.
And then the code.
Yada, yada, yada.
Over code.